Hello, Algebra 1. Today you're going to be learning how to factor something when you have a number in front of your x squared. So this is a really important topic and there's only one extra step that we need to learn. So let's take a look. Today we will work on, this is called factoring, some more. Remember, this is the same as just reverse FOIL. Today, however, there will be a number in front of our x squared, which means we are going to have to pull out what's called a GCF, or you may know this as a greatest common factor first. Okay, so our rules are still the same. We're multiplying to this number at the end and we're adding to the number in the middle. Usually the GCF is just the number in front of x squared. However, if we have an x cubed term, and this will be different than what you're used to, you should look and see if each term also has an extra x. And if it does, we'll need to pull out an x as well. Okay, so let's take a look at this and let's see what we can do. So you'll notice for number 1, instead of having an x squared, we have a 5x squared. So what you're going to do is check and see if 5 goes into each term evenly. So does 5 go into 15? Yes. Does 5 go into 10? Yes. That means that 5 is our GCF. Okay, and if you're not sure, you can just divide. So then 2 is our next one. That's in front of x squared. We'll check that first. Does 2 go into 28 evenly? Well, yes, because 28 is an even number. See how it divides evenly? And then 98, we can divide that by 2 as well. Yep, it divides evenly. That means 2 is a GCF. Now, if you look at 3, 3 is like the problem we're used to factoring. It just has a 1 in front. So 1 is our GCF. This is something we would just factor like normal, like we were working on last week. Okay, now 4 is a little different, and that's because you do still have a 1 in front, so it seems like it's the same type of problem as before. But what you should notice is that you have an x cubed term. So if you notice, each of your terms here has one more x than it should. That means our GCF is an x. Okay. All right, come down to number 5. You have a number in front, so first we'll check that out. 5 does go into 15 and 20 evenly, so we will have a 5 as a GCF. However, you may also notice that you have this x cubed. See how each of these terms has one more x than it should? That means our GCF is really a 5x. Okay, and finally, our 2 is in front of our x squared. Okay, 2 does go into 50 evenly. I can check by just dividing by 2. Yep, no decimal there. That means 2 is my GCF. Notice I don't have an extra x. It's not an x cubed. So that means there isn't a GCF or greatest common factor of x. It's just the 2. All right, so now let's go ahead and try this. There are 2 steps for GCF box problems. Step 1 is you're going to divide out the GCF from each term, and step 2 is you're just going to do your box problem like normal. Okay, so here's an example. You have 4x squared plus 32x plus 48. You should notice you have a 4 in front, and 4 does divide into each of these evenly. That means 4 is my GCF. It's going to come out front. And now what I'm going to do is basically reverse distributive property. So 4x squared, when I divide it by 4, I just get an x squared. 32, when I divide it by 4, I get an 8. So this is going to be an 8x. And 48, I'm going to divide it by 4, and I get a 12. Okay, now to make sure I did this right, you can think of distributive property. 4 times x squared is 4x squared. 4 times 8x is 32x. 4 times 12 is 48. That's how you know you did it correctly. Okay, your 4 is going to come down, and now what you're going to do is just your normal box problem for this part right here in parentheses. We are going to multiply to 12, and we're going to add to 8. and those numbers should be 6 and 2. And we fill them in, and you'll notice the only difference is that you have that 4 in front. Okay, now this is important. This first step does have to happen. The mistake that people make is they come up here and they say, oh, what multiplies to 48 and what adds to 32? You aren't going to find anything. And so people want to say it's prime. You must divide out your greatest common factor first. Okay, so that's what we're going to practice today. All right, and we're just going to do number 1 through 8, and then you'll have a Canvas quiz to do today. Okay, so again, factor the following expressions using a GCF box problem. Remember to pull out the GCF first. If you have a number in front of x squared, you must pull out your GCF first, okay, before you can do your box problem. All right, so 2 steps for each of these problems. Step 1, identify if you have a number in front. I do. Check, does 5 divide evenly into each of those numbers? It does. So I'm going to bring out my 5. Open up my parentheses, and now I'm basically going to do reverse distributive property. 5 times what is 5x squared? Just an x squared. 5 times what is 15x? Well, 5 times 3 is 15x. 5 times what is 10? Well, 5 times 2. All right, and if they're bigger numbers and you're not sure about your mental math, just divide it. 15 divided by your GCF is 3, that's why I have 3x, and 10 divided by my GCF is 2. Okay, so that's step 1, dividing out my GCF. Step 2, bring your GCF down, and now you're just going to do your box problem like normal, but you're doing your box problem with this, okay? We're multiplying to 2, we're adding to 3, and that's going to be just a 2, a positive 2, and a positive 1. Okay, and there's my answer. All right, so 2 steps. Let's try it again. Number 2, see if you have a number in front of x squared. I do. Check to see if it divides evenly. I think we actually did this one already. 28 divided by 2. Yes, it divides. 98 divided by 2. Yes, it divides. These are numbers I'll actually end up using here. So the 2 comes out. Reverse distributive property. 2 times what is 2x squared? Well, just x squared. 2 times what is 28x? Well, I already did that. It was 2 times 14. Just don't lose your x. 2 times what is 98? Well, I just did that. It was 49. Okay, now we do our box problem. We are multiplying to 49. We are adding to 14. I'm going to bring down my 2 and I'm going to set this up. Make sure that 2 is there. Your numbers should be a positive 7 and a positive 7. And if you would like, you can rewrite that as so. Okay, either of these answers is acceptable. But notice that GCF is out front. It does need to be there. All right, let's try another one. Number 3. Check, we have a number out front of x squared. Make sure it goes into each of these evenly. So I know 3 goes into 15 evenly. What about 72? Okay, it does. So we'll pull out our 3. 3 times what is 3x squared? X squared. 3 times what is 15x? It's a 5. 3 times what is 72? Well, I just did that. It was 24. Bring down your 3. Set it up. Okay, again, this is always going to be a 2-step problem when you have a number in front there. We are finding the box problem for this guy. So we're multiplying to negative 24. We are adding to 5. And that should be a positive 8 and a negative 3. Make sure your 3 is out front. All right, we've got 5 more. Let's see what we can do. So again, step 1, identify if you have a number in front of x squared. We do. Next, check if that number goes into each of these evenly. It does. So the 4 comes out. Now some of you may be asking, well, what if that 4 doesn't go into everything? Like what if this were a 33? Well, it's not necessarily prime. It's possible that it can still be factored, but that's something you're not going to learn until you're a junior. Okay, so for our problems, you'll always be able to pull that number out. That number will be the GCF, but in the future, it might not be. Okay, so that's kind of the short answer to that. All right, so now we do reverse distributive property. 4 times something is 4x squared, just an x squared. 4 times what is 8x? So 2x. 4 times what is 32? It's an 8, and it's going to be a minus since that's a minus. Okay, now we'll go ahead, we'll do our box problem. My setup, I'm going to keep my 4. I'm going to bring down my parentheses. Okay, again, this is GCF factoring. I'm multiplying to -8, and I'm adding to -2. Okay, so it's going to be a positive and a negative since I'm multiplying to a negative. And it should be 4 and 2, but the 4 needs to be my -1. Okay, and there's your answer. All right, now look at number 5. See how number 5 doesn't have a number in front of x squared? If you want, you can go ahead and you can put a 1, but here's what we're going to focus on more next week, the difference between these. This is just a regular factoring problem. Because you don't have this number in front, you don't need to do the first step. You can go straight to the box. Multiplies to 6, adds to -5. And that's going to be a -3 and a -2. Okay, see what I mean? There's no number in front of x squared other than a 1, so we don't have to divide out that number. We don't have to do that first step. Okay, but back to number 6, we do have a number in front. We have a 3. Let's check, does 3 go into 75? It does, so I will divide that 3 out. Reverse distributive property. 3 times something is x squared, or excuse me, 3x squared. And then 3 times it was 25 equals 75. Okay, so this is still a box problem. Remember, this is the same as multiplying to -25 and adding to 0. And that should be a 5 and a -5. So that's x plus 5, x minus 5. And there you go. All right, our last two are a little different. You're going to notice there isn't a number in front of x squared. In fact, there isn't an x squared at the beginning at all. Both 7 and 8 have x cubes. So when you have an x cubed, what you're going to look at is see, is there an extra x for every single term? Like what we should have is x squared, x, and a number. And instead, we have x cubed, x squared, and x. So what that means is everything has an extra x, and x is our GCF. Okay, it's the extra thing that the x squared has. So when we take an x away from x cubed, we'll be back to x squared. X times what is 7x squared? Well, that's just a 7x. We've taken that x away, so now it's back to what it should be. And when we take the x away from the 12x, when we divide it out, we just get a 12. Okay, and then we're going to do our box problem with this guy right here. Multiplies to 12, adds to 7. And that should be a 4 and a 3. Okay, let's try one more like that. There isn't a number in front of our x squared, but notice that each of these have one extra x. That means our GCF is an x. And now we're going to go ahead, we're going to take that out. When you take an x from x cubed, it is x squared. Plus, take an x from 9x squared, it's 9x. And really we're dividing this x out. And then divide again, and we'll get -36. And now we're going to multiply to -36, and we're going to add to 9. Okay, and that's going to be let's see, 9 times, well, 9 times 4 is 36, but that doesn't add to 9. Ooh, this one's tricky. This is going to be a 12 and a 3. It will be a positive and a negative, and our 12 will need to be the positive one since it's adding to a positive 9. Okay, and then we'll just keep that x out front. All right, so there you go. What we're going to do tomorrow is we'll continue on this note sheet, and we will do these problems here that will involve zero product property. Okay, so we are going to spend 2 days on this note sheet. So now you will go ahead and you will complete your Canvas quiz and let me know if you have any questions. Have a great day. Bye.